Hi everyone, video 2 on Newton's laws of restitution. Remember, separation over approach. Separation over approach. Okay, this time though we're talking about successive impacts, and that means when more than one thing is colliding with each other. And really, even though it might seem a bit complicated, it's not. It's the same thing over and over. Newton's laws, finding out what E is and using comp as well. So let's have a go. So we've got three spheres, A, B, and C. So A, B, C. The most important thing here is just keeping track of all of your particles and what's happening with them. Have masses M, 2M, and 3M. Cool. The spheres move along the same line. A following B, which is following C. That's how I knew it was in that order, A, B, C. Initially, and it also tells me the directions as well. Initially, the velocities of A, B, and C are 7. So 7 meters per second. We've got 3 meters per second. And C, we've got 1 meters per second. And sphere A collides with B. So there's an E corresponding with that. And you know we should normally put I's in there for impulse. And then B collides with C. The coefficient of restitution between A and B is a half. Brilliant. And the coefficient of restitution between B and C is a quarter. Great. Find the velocities of the three spheres after the second collision. So, how to begin? First, we need to know it says that A hits B first. So we're going to isolate this section here. Like I say, important to keep track of what's going on. So there's an impulse here, and it doesn't tell us the final velocity. So as we know from the last video, I'm just going to assume they're all going to the right. So Newton's law of restitution, E is difference in speed of separation, and remember B must be fastest because I've assumed that it's going to the right, and the fastest going to the right, because my positive direction is right, is this 7, and the 3 is also going to the right, so that's why it's the same sign. And I know that E is a half, so therefore I get VB take VA is 4 over 2, which is 2, so I get VB is 2 plus VA. Cool. And we've got two unknowns, so we need two equations. So we're going to need comp. We'll go to the right again. So 7m plus 3 times 2m equals VAm plus 2m VB. And those m's cancel. 7 plus 6 is 13. And we get VA plus 2VB. We know we need to sub in VB then. So we get VA plus 2 lots of that is 4, plus 2 lots of VA is 2VA. So we should get VA equals, what's that? 9 over 3, so 3 meters per second. That's cool. What's VB then? VB is 2 plus VA, so that means 5 meters per second. Does the direction change? No, because I assumed it was all going to the right from my diagram, and my numbers are positive. So therefore the direction is unchanged, okay? But we want to know what happens on the second collision. So that was the first. So I would write first, and then I would write second. And we're going to need a clean diagram here, really, aren't we? A clean diagram with our new information. Because B, what's happening is that VB has now become UB for when it hits C. See? So new clean diagram between B and C. How would I notate that UB? I'd call that UB dash, because that's the new value for its starting velocity, and we know that's at 5 meters per second. UC is still traveling at 1 meter per second, so 2m, 3m, and again I don't know what's going to happen to VB after, so I'm going to call that VB dash because it's a separate VB to this one. And VC, well, that hasn't been hit yet, so that's still just going to be VC. Impulse in there, and we know E is a quarter. So same process, folks. Newton's laws of restitution. E is a quarter. We've got our VC must be faster this time than VB dash, and 5 and 1 are going in the same direction, so the difference is 4. So we get VC, 4 times that is 1, plus our VB dash. So there we go. We now need our comp again. So comp, and we're going to go to the right. So the same process, folks. So 10m plus 3m equals 2m times VB dash plus 3m times VC. M's cancel, so I get 13 equals, that's interesting, 13, fine, 13, so 2 VB dash plus 3 VC, and we know that VC is 1 plus VB dash, so 13, 2 lots of VB dash plus 3 lots of VC, so that's 3 plus 3 VB dash, and this means we get VB dash equals, what's that, 13 take 3 is 10, divided by 5 is 2, so VB dash is 2, and VC then must be 1 plus 2, so 3. Again, they have not changed direction because I assumed it was all going to the right. So what does that mean? Well, let's just draw a clean diagram to see what happens, because this is what will happen next, yeah? So at the end, what's happening is we know that VA was 3 meters per second. So that means our new UA is 3 meters per second. So A, B, C. So UA dash is 3 meters per second. Okay. What else did we end up with? The new VB dash was 2. So that's becomes our UB dash dash is 2. And C, what was happening with C? Well, C was 3. So that becomes UC dash is 3. So what's going to happen again? Well, what's going to happen next? So first A hit B, and then B hit C, and B had a new speed there. But now B has slowed down to 2, hasn't it? So B isn't going to hit C again because C is at 3 and B is at 2. But A is actually traveling faster than B. So what's going to happen next? A will hit B again. Do you see? Because this speed is now faster than the 2. Okay, next question. So I gave you 2 slides there to write in that. Right. So this one's important though. This is important. A and B is standard, but then part C is really important. So we'll go through this bit quickly because we've done lots of this now. So or just pause it, you do it, and then skip through to the part C and see if you agree with what I've got. But part B and C are important. Uniform smooth sphere, so P, mass 3m, moving with speed u, so there's u, and we've got a q in the same straight line but in the opposite direction, so this has mass m and uq is 2u. Collides, so I've got my impulse, I've got my e, velocity of vp, and so velocity of p after the collision is v, so vp, we call that v, and q, so vq, they're calling that w, fine. And we don't know whether they change direction, so I am just assuming that it's going to the right again. If in doubt, just assume it's going to the right. So first find v and w, so we're very used to doing this now. So I assume to the right, w must be faster than v, otherwise it's just going to keep hitting it, but be careful here. fastest in the direction that I've said first. That's this one, u. Take away 2u, but in the opposite direction. So be careful of that. Okay, so we're going to get 3ue timesing up is w take v. So therefore w is 3ue plus v. There we go, first expression. Where's the second one coming from? Comp, yes. Yes. Okay, so we get 3um plus, but it's not going to be plus, it's going to be minus. So let's get rid of that. So 3um minus, because it's going in the opposite direction, 2um is 3mv plus mw. So m's are going to cancel. We get u equals 3v plus w, and we know w is that thing over here. So 3v plus 3ue plus v. Okay, cool. So therefore we get u take 3ue is 4v. So v must be u over 4, 1 take 3e. So again, if you're not confident with that, just pause the video and do it yourself. Okay, cool. And also w then, we know, is 3ue plus that v. And that v was u over 4 minus 3ue over 4. So that's over 4, so that makes that 12. So w is u over 4 plus 9ue over 4. So u over 4, 1 plus 9e. I'll rub that out, doesn't look very clear. Again, I'm kind of doing this fast, folks, so I could make mistakes, arguably. And that's why you should be doing this at the same time and checking. Okay, so I've got my u and v. Wicked. B says show that if the direction of P is changed by the collision, then E must be greater than a third. Now, we have talked about change, but this is excellent because it's another example. So part B, so important you understand. I assumed that the direction was unchanged for P. I assumed it was going to the right. So I assume my answer is positive. But actually, my answer is wrong. Well, my assumption was wrong. The direction of the motion has changed, which means VP can't be positive. VP must be negative, right? Because I assumed positive was to the right, but actually it's going to the left, so I need to times my answer by minus 1 effectively. Well, not times it by, well, that is what's going to happen. So let's see what I'm saying here. Forget what I said about timesing it by minus 1. Just if you understand that VP must be negative, because I assumed it was to the right, when actually it's to the left, then you're on your way. So 1 minus 3e is actually less than 0. My answer must be negative if I assume it's going to the right. So I can divide by the u over 4, that's gone. I get 1 minus 3e is less than 0. So I can move the minus 1 over, divide by the minus 3. That changes the inequality sign, and e is greater than a third, like it says. But we know e can't be bigger. Watch out for this. The question really should state that e must be between 1 and a third. Okay, so good going back to that theory again. But C, important now. Following the collision with P, the sphere Q then collides with and rebounds from a wall perpendicular to the direction of motion of Q. Okay, how do we draw a wall? Well, wall we're going to draw like this. Here's the ball Q. We know that UQ dash, so after it's hit P, Q's speed has changed, hasn't it? And we know that that speed was, what was it? It was W, wasn't it? And W must be positive because looking at this expression here, that must be positive. So U over 4, because E can't be negative, can it? So U over 4, 1 plus 9E, that's good. And it says, so there's the wall. And remember the wall, I'm going to call that W, and the wall's stationary. So I'm going to call that UW going 0, right? We know the mass of Q was M, and it's telling us the coefficient restitution is E prime. So let's call that E prime. It says given E is 5/9, that means I know what UQ dash is now. So UQ dash, if I whack in 5/9 for E, that's going to be 1 plus 5/4, so that's 3U/2. I hope you followed that. Just whack in for E, 5/9, the 9's cancel, and you get 3U/2. Wicked. Now, what's going to happen, VQ? Obviously, VQ prime is going to rebound. It's going to go to the left, isn't it? It doesn't matter whether I assume it goes right or left. It literally doesn't matter, as long as I'm consistent with my arrows and my notation. All right? So it says, show that E prime must be bigger than 1/9, given that P and Q collide again. That's the most important thing. That tells me straight away, if they collide again, then Q's new speed, this one, must be bigger than P's new speed, right? Because the direction of motion of P is changed. P is traveling that way. So in order for Q to hit P, that speed, this one, for it to catch up and hit it, must be bigger. So that's what I'm going to show, right? Get your logic right first before you approach the problem. So let's go for it. So Newton's restitution, I'll go to the right. Why not? Because it doesn't matter. I just need to be consistent. So E prime, speed of separation, difference. What's the one going to the right? This one. So 0 minus. What's the one going to the left? Well, here, minus VQ prime. So it literally doesn't matter what I pick. Go to the right. We've got speed of approach now, the difference of. What's the fastest going to the right? Well, it's this 3U/2. Take away. This one's going to the right, 0. All right? So I get E prime is VQ prime over 3U/2. Okay, cool. And therefore, I get VQ prime must be 3U E prime over 2. That's good. Now, remember what we said. VQ prime needs to be bigger. So if P hits Q, if Q hits P again, VQ prime must be bigger than VP, mustn't it? So we need to remind ourselves, well, we know VQ prime is 3UE prime over 2. And what is VP? I forgot. VP was U/4 1 minus 3E. So let's put this to the side. VP was U/4 1 minus 3E. And we know that E was 5/9. So that's going to be U/4 1 minus 3 times 5/9. So 5/3. And that means we're going to get minus 2/3 times that. So minus 2/3 times U/4 is going to be minus U/6. Okay. Let's double check that. Yeah, that's cool. Cool. Right. Now, notice I've got VP as a negative number. Exactly. That's exactly the point. VP is a negative number because remember I assumed VP was going to the right. And we said, well, VP must be negative for part B. Exactly. Exactly. And I am getting a negative because VP isn't going to the right. It's actually going to the left. So the speed of VP to the left is U/6. Do you see? So this thing, VQ prime, must be bigger than U/6. So E prime equals, if I times by 2, divide by 3, the U cancels, I'm going to get 1/9. Perfect. Which is exactly what the question asked for. So important that you understand And it visually showed there that VP was negative because I assumed it was going to the right. I got a negative answer, which means it must be going to the left. Its speed is u over 6 to the left. Well, I shouldn't really say to the left, direction reverse, let's say. Okay, hopefully that's helped. I really recommend you try that question again if you struggled with that to understand conceptually what's going on. But if you have that, like everything falls into place. The whole topic is done. Okay. Cheers.